Hello friends, I am Saroj Vishwas, gold medalist, first rank holder of 1994 batch in engineering stream of all the colleges affiliated to University of Mysore during that period. A BE in civil engineering from National Institute of Engineering Mysore, a MTech in structural engineering from Indian Institute of Technology, Delhi, that is IIT Delhi, a Sun certified Java programmer, Sun Microsystem USA. I have more than 25 years of professional experience in designing building structures and allied subsidiaries. I invite you all to learn with me how to design building structures using commercially available structural softwares with the help of some manual computation as and when needed. In last section, we had created the foundation model. In these sections, we will discuss how to add load combination for RCC design, and then we shall design the pedestal and we shall check what is the reinforcement requirement of the pedestal and detail the reinforcement for these pedestals. So to define load combination, it is nothing but it will be same load combinations for limit state design. So we have only the primary load cases. It will have the same load cases, same load combinations as we use for steel design, except one of the load combinations in which we have a 0.6 factor for lateral load. So let us open our hypothetical steel building model. So this was our model. We'll use the load combinations from here. Let us open the editor. Let us take all the load combinations from here, because we had already defined the primary load according to the load combinations of this file itself. So we can use this load combination. So we shall take the foundation design load combination also. So this is the selection up to the foundation design. So let us copy it, Ctrl C, then let us open our foundation substructure file. So let us place it here. Now we do not have the dynamic load cases for our foundation design, so we have to remove this. We shall keep only the static values. So we delete this. So we have the static load cases, the wind load combinations. For serviceability, we will not require for foundation design. For plinth beam deflections, that can be checked from the graphical user interface of the model itself. So, for foundation design, load combinations are also there. Note that for foundation design, load combinations all shall be the working load, that is it shall have, all the load shall have a load factor of on only. So, and these are our limit strength design load combinations, and we actually do not need this. We may leave it as it is, since we are designing steel structures. So it is better to leave this load combination as it is. There is no problem if it is designed, if the pedestal is designed for this load combinations as well. So let us save it, and so this is our model. Now if I go to the load, we can see the load combinations as well, the foundation load as well. The next step is to give the concrete design command. Go to design, engine, then click on concrete tab on the left hand pane, then select IS456, then define parameter. Let us select the model, then define parameter. Or concrete strength shall be M25, so 25,000 kN per meter square. Assign. Main reinforcement shall be FY 500, so 500,000 kN per meter. Assign. Or secondary member shall be 500, so 500,000 km assigned. The next step is to provide design command for the beam. Select specification, property name, this is our beam, this is our Plinths beam, so command design beam assign. Then select by specification, property name or Plinths beam, then rigid. Select by inverse beam selection, so we do not require these things to design as column, so let us assign design column. So we can detail these beams in both the way as ordinary frame as well, but at times many structural engineers might want to ask, might look for seismic detailing of these pedestals and the Plinths beams. So for those cases, if we go to IS1893, clause number 6.4.3. For structural analysis, the moment of inertia shall be taken as in RC masonry structure 70% of I gross of the column and 35% of I gross of the beam. Okay, so our is a RCC substructure. So we shall assign 35% of the I gross to this Plinths beam So select by specification, property name. This is our plinth beam. Go to command, member specification, crack property. So we'll release reduction for cross sectional area will remain same. We'll release this torsional value because code allows us to neglect torsion if it is in equilibrium, if equilibrium can be sustained. So if we reduce the torsion to 0, there could be numerical instability. So we shall make this torsional constant 0.00, that is along the centroidal axis. Then along the major axis, the beam shall have 35% of the, so in both major and minor direction 35%, so 0.35 assigned. Now let us select all the columns. Select beam parallel to Y, select beam parallel to Y, only the columns you have to select it. Then again go to command, member specification, crack property. So for column we shall not reduce the factor for torsion constant, so only the gross inertia about the major and minor axis. So assign. So now let us go to the command file, SC. You can see the crack properties has been assigned. So let us close this command file. Now let us give it a run. So you can see there are some warnings. Depth less than depth to length of the depth of for beam 72, 74. So these are the beam at the corners, so we can ignore them. So these are not actually that kind of deep beam. So since the stud its length as node to node, that is why this warnings has been issued by STAAD. So let us now check the reinforcement. So you can see the reinforcement is almost all of them has 0.8%. So let us first select by type of the pedestal, select by specification, property name, these are our corners one. So let us note down the reinforcement at some place. So let us open Excel file. Let us make this like this. So these are 3480, 3480. So this, let us consider this as P1. P1 has reinforced 3480 mm square. The size is 750 by 580. 750 by 580. Then select by selection second one. So this is P2. Let us consider this as an reinforcement of 3640. The size is 720 by 532. And select by specification, property name. This is the force. Let us see what is the maximum. 3255 and 3255, 3255, 3255. So all of them has 3255. If they have a different, we should have taken maximum reinforcement. mm square. The size is 775 by 525. Select by section property name. Here interior 700 by 430 E4. Let us see what is the reinforcement. 2480, 2408. So these we can consider P4. 2408 square. The size is 700 by 430. 700 by 430. So select by section property name again. This is our corner 1, 2 corners 1. The reinforcement is 3918. 3918. The size is 750 by 653. P5. Reinforcement 3918. Size is 750 by 653. This is our P5. Then lastly, select by section property name. P6. 630 by 350. The reinforcement is 1750. P6. 1750. 625 by 350. Now note that for all practical purposes, we should define them to a rounded value. So we can make this 532 as 535. 430 is okay. 653 is 660. 535 540. So in drawing we shall provide this kind of sizes. So, minor variation in the sizes from the STAAD will not change much value. If required, we can change the sizes to match with the sizes we are providing and then check the reinforcement. So here it is a very minor difference. In order to go round up the values, so the reinforcement will not change. If at all it changes, it will be a very minor variation. There will be a very minor variation. The next step is to size the pedestals. The next step is to provide the reinforcement detail for the pedestal. So we have this Excel sheet. Our reinforcement requirement for P1 is 3480 mm square, P2 3064 mm square, P3 325 mm square, similar for others. So this is P6. So let us try for the reinforcement detail for P1. Now before that, we are considering the diameter of ties is 48.5. In a pedestal, the minimum number of bars should be 4. When the spacing of longitudinal bar is less than all round ties around the alternate bar should be. This is not required. So, if the distance between the longitudinal bar with all round ties is less than 4, then the intermediate bars can have open ties. Okay. So, and Control Z. Ties should be there in alternate ties. Ties should be there around ties should be there for the alternate bar. The maximum spacing of the bar, this we can go for 48 pies here. Maximum spacing of the bar should be 150, that is okay. Maximum spacing of the bar with all round ties 384 mm with 48 5 ties, 48 into 5 ties are the stirrups. Minimum clear spacing between the main bar should be 25 mm. These are the details which has been taken from IS456 and SP34. These are the some drawings that has been given in page number 87 of SP34. You can refer to this detail how the reinforcement for a column should be there. Here our length of the column is quite high. It is so these pedestals will actually behave as a column because the length is around length is 2.05, so we cannot consider it is a strut. So coming back to the Excel spreadsheet, so our first pedestal is 750 by 580. Let us consider diameter of a bigger bar as 16 mm, diameter of the smaller bar as 12 mm. Clear cover to the bar for a column is 40 mm. So our long side is 750 mm. So this is the field we need to fill it. This type of Excel file you should prepare before detailing, or you can do it on a sketch also if you can remember all these conditions. So these are the things I am making in green because these are the record field which are to be filled. So 750 and then this is 580. So we are taking number of bar as 16. So this is our case 4. Let us go to the case 1, case 2, case 3, case 4. So our requirement of steel was 3480. So in case 4, 3217, we are getting 16 number of 16 dia. So if we change it, let us change it 20 mm and 16 mm. Then let's see what is the condition. Case number 4. This is quite high. This is 3660 mm. So our requirement was 3480. So we can make another cell here. Steel requirement is equal to 3480 mm square we can put here, or the case number 4, steel required is equal to, let us link it, 3480. Then let us press F4 by selecting this. So mm square, cut and paste. Sorry, this is copy, Control C, Control V and Control V. So this suits our requirement. So it is more than 75. There is a tie here. So there is open tie. We can provide open tie because 48 5 to 325. This is 384. This is less than 325. That is 325. This is again less than 384. So 325. So this detail is okay. So let us copy this. Copy in pedestal detail, paste special values. So it is not coming. So let us do one thing. This is our pedestal on. Let us take the snipping tool, edit, new snip, edit. We can put off the grid line. So snipping tool, new snip. This is our pedestal on. Edit, copy, go to pedestal, paste. You can write it, format shell, alignment, mask cell, P1. This detail we can provide to the detailer for detailing. This is P1. Now let us go for P2. For P2, The reinforcement required is 3064. Size is 720 by 540, 720 by 540. Let us still keep 16 bars. This should make 16 bar. Die of the bigger bar will keep 16. Die of the smaller bar will keep 12. Clear cover. So case number 4 again. So still required is 306. So this best suits our requirement. So let us take the snipping tool. New. Edit. Copy. Go to the next sheet. Paste. Resize it. Copy. Paste. This is our P2. Then let us go to P3. P3 is 775, and other size is 525. Still we are keeping 16 numbers. So again case 4 will be valid. So reinforcement required. What is the required reinforcement? Required reinforcement is 3255. So 3217 is the record still. So P3 will also have same detail. Edit, copy, paste. So this is our P3 detail. We should also mention the sizes. Or P1 is 750 by 580. So P1 750 by 580. P2 is 720 by 540. Let us make the height, row height 16, copy, paste. Or P2 is 720 by 540, 720 by 540, and P3 is 770 by 525, 775 by 525. And we should also write the required spacing of the stirrups. So let us go to the start file. Complete design. So this is our beam number 1. Let us go to the column number 22. Which shall provide 8 mm dia rectangular ties at 190 mm center to center. So this we can copy, Ctrl C, okay. Then go back to the design sheet, pedestal detail, paste. So This is now we have to detail the pedestal as per IS 13980 2016. So let us open the code. Project code is here. So 1312390. So this there is a figure given. You can see the column. This is one of the Excel file which I have prepared for beam detailing as per IS 13920. So before we detail the beam as per IS 13920, we must design the beam. Check the design of the beam as per IS 456. Let us open the start file. So if you click, there are 310, 310, 310. Everywhere it is 310 if you check. But in actual practice, we do not provide 10 bar in a beam. So the dimension of the beam is 230 by 450. So let us go back to the Excel file. So this beam, we shall consider this beam. This beam. So this is along Z direction. So let us open this Z direction beam. So we are providing 12 dia. Our beam is 230. So let us link all of them. 230, 450, and this should have been then 230, 450, 230, 450. So here there is no beam, left beam data. We are for practical purpose to show the detailing as per IS 13920. I am assuming that we shall have two extra 12 dia bar at top near the support, near the pedestal. So extra bars, 2 extra, 16. So left beam is sagging and right beam is hogging. So in tension reinforcement it will be 12, 12, 0 and 12, 3, 12 and 2, 12. This is the tension reinforcement on the left hand side, and compression reinforcement will be 3, 12. There will be no reinforcement. So on the right hand side it will be exactly opposite. So this will be, so we have fitted 3, 12, 3, 12, 0, 12. This is at sagging. So this will be the tension reinforcement, and here it will be the compression. On the right hand side it will be, top will be the tension reinforcement and the bottom will be the compression reinforcement. Similarly, for soil left, that case will be opposite to that. So these are the equations that has been prepared using first principle to get the moment of resistance of the beam. So we have moment of resistance of the beam is 63.1, 104.2. So let us go to the beam detail. So we have obtained the moment from there. This I have put it green shell because we might have to again link it, whether it is a Z direction beam or a X direction beam, before we detail it. So these are again linked to. So these values are linked here. So let us go clause one by one. So maximum compressive stress, allowable stress 1, so 0.05 is actual compressive stress obtained. Then y to the point greater to b by d is equal to 0.51. So this is also okay. Beam depth is greater than beam. This should be beam width. Beam width should be greater than 200 mm. So that is also okay. Then beam depth should be less than clear span. So LC by 4. This should be. So this is also okay. Then width of the beam is smaller of 2D. So minimum dia of the bar, the top and bottom. So minimum dia is provided is, this is not linked. So this is linked to the X direction. So we have to link it to the Z direction. Make it green as well, so that we might require to put it. So along you have to link this here. So here we have this as per STAAD design. So you can see all the provisions has been taken care of. So our number of leg here is we should add this modification factor, because at times we might not get full LD here when the column terminates. So in that case we might have to reduce this SC and SC and ST as per requirement. So we should take care of that as well. So with this, the Plinths beam detailing with as per IS13920 is complete. In next section we shall see the detailing of pedestal as per IS13920, and will also design some typical footings, 1 or 2 footings. So let us see you on the next class. Before I close, let us go back to this part also. These are the equations to drive the required link spacing. So these are the equation taken from IS13920. So these are the moment, that is a moment of resistance of the beam. From this we get the moment of resistance. Now you see one thing here, at mid span or beyond support,
the shear force shall be as per our analysis, or minimum of from analysis, or from analysis, or from analysis because of dead and live load, and or from this shear developed from because of moment of resistance of the beams. So for mid-span part we should look into here as well. So I request all of you to go through the code to understand it properly. So in next class, as I already told, we shall go to the pedestal detail and few footing designs. Thank you.